Hey YouTube, welcome back. So, is your application starting to feel like sluggish? And the database queries are taking too long than they used to do? Sometimes the simplest solution are the most effective ones. Today, we are diving into vertical scaling, a fundamental way to boost your database performance by simply making your existing server more powerful. Okay, so what is exactly vertical scaling? Um, yeah, hey. So let's start with the most intuitive approach, which is vertical scaling, often called scaling up. So let's take our pen. Let's say that we have our server here. This is our database server. Okay, so let's call it S1. So think of it like upgrading your personal computer. When it gets slow, you add more RAM or a faster processor. In the database world, this means beefing up your existing server with more powerful resource or with more powerful machine. This could involve like upgrading the CPU to one with more cores and higher clock speeds, and maybe adding more RAM to handle larger datasets in memory for faster access, for example, or maybe increasing disk storage for growing data volumes or improving network bandwidth for quicker data transfer. So, in simpler word, vertical scaling, you take your server and you just upgrade it. You add more resources to it, add more RAM, disk storage, etc. But you just make the machine bigger and more powerful. Okay, how to implement it? I would say there is three ways. The first one, it's like a physical hardware upgrade. Like if you manage your own servers on premise, this means physically replacing the hardware with a more powerful machine. A complete server upgrade. This might involve installing a new a motherboard with a better CPU, adding more adding more RAM sticks, or swapping out old hard drives for faster SSDs or larger capacity. Next, we can talk about cloud cloud provider resizing. Like if you are leveraging the cloud with providers like AWS or Google Cloud or Azure, the process is often much simpler. You can often dynamically resize database instances with just a few clicks in their management console or through their APIs. For example, you might upgrade from a smaller instance type to a significantly larger one with more CPU, RAM, and faster storage. Okay, I guess you can do some sort of database, also database engine optimization. Beyond just the hardware, you can also optimize database engine itself. This involves tuning configuration parameters like increasing the buffer pool size in MySQL, for example, which acts as in-memory cache for frequently accessed data, or allocating more shared memory in Postgres for similar performance gains. Maybe you can ask like faster storage as well. Here, like finally, this is significant performance boost can come from switching to a faster storage, like moving from traditional HDDs to SSD, or even to ultra fast, which is NVMe drives. That can it can drastically reduce the disk I/O bottlenecks, leading to much quicker read and write operations. And I would say mostly you find yourself using the cloud provider resizing, because I guess most of the application using AWS or Google Cloud. Okay, next, when to consider vertical scaling. When? So I would say you use them first in your early growth state. It's often a great first step when your application is starting to grow and you need performance boost without introducing the complexity of distributed systems. Also, if you need a simpler maintenance. If you prioritize simpler maintenance and want to avoid the operational overhead of managing multiple databases or not multiple database nodes, vertical scaling keeps things relatively straightforward. Also, let me delete that. If you are looking for a low latency requirement, when low latency is critical for your application and the overhead of distributing queries across multiple nodes is understandable, keeping everything in one single powerful machine can be quite beneficial. And also, if you need like a quick and cost-effective, quick and cost-effective initially. So in short term, especially in the cloud, the vertical scaling can be quick and relatively cost-effective to address performance issues without significant architecture. Okay. Next, we need to talk about the limitation. I would say there are four problems. The first thing, we have a hardware ceiling. Like there is a physical limit to how much you can upgrade a single machine. Even the most powerful cloud instances have maximum resource allocations. Eventually, you will hit a point where you can't add more any more powers. Number two, a single point of failure is SPOF. A vertically scaled database, it's still just a single machine. If that server experiences a hardware failure or crashes, your entire database goes down, leading to application downtime, unless you have like additional failover mechanism which add more complexity. Number three, expansion, high cost or expansional cost. Let's call it easy. Like beyond a certain point, the cost of these high-end top-tier machines grows exponentially. The most powerful cloud database instances can become incredibly expensive. And I guess lastly, we want to talk about there is some sort of downtime during upgrade, like especially in on-premise environments. Freezing CPU memory or disk space often requires scheduled downtime to perform the physical upgrades. Okay, vertical scaling is simple, effective, and often the easiest first step to improve your database performance. It's like giving your current engine a powerful turbo boost. However, as your application continue to grow and demand even more resources, you will eventually hit the limitations of a single machine. That's when you will need to start exploring horizontal scaling techniques, which we will cover, I guess, in the next videos quite soon. So yeah, that's it for this video, and see you guys in future videos.